Okay, let's have a look at some of these recursive problems then. I think the first one we'll have a look at is actually Fibonacci. I've been doing some of the other ones in class, but this one I didn't actually do with the students, so this is a great opportunity to practice it. Let's have a look at our problem. Okay, the Fibonacci sequence is a famous bit of mathematics and it happens to have a recursive definition. Very helpful for us. The first two values in the sequence are 0 and 1. Essentially the two base cases. So remember, the base cases are the ones that we have to catch and are essentially our stopping conditions so that our stack doesn't overflow. In the first two questions there was one base case and now there's two, and it's letting us know that. Each subsequent term is the value of the previous two terms. So the whole sequence is 0, 1, 1. You see when you get to 2, it's 2 plus the one before it and the one before that. 3 is the value of that n is n minus 1 and n minus 2. Of 5, it's n minus 1 and n minus 2. Of 8, it's n minus 1 and n minus 2. That's how it works. And we need to define a recursive Fibonacci that returns the nth Fibonacci number. So not the total. It's if we put in 5, what is the number at that point in the sequence? Okay. Whenever I'm doing recursion, the first thing I want to do is I want to put in the base case, and they've let us know what the base case is, which is, that's not helpful, which is if n is equal to 0 or n is equal to 1, you're very welcome to also do this as two separate if statements that work the same way, or an if and an else if. What do we do? Well, in the case of if n is 0, we're going to be adding, so we can add 0 to itself if it's 0. 1 we should be adding to itself if it's 1. So in this case, we add n to itself. And then we would need to do return. And if you remember, we said it's the value of any item is n minus 1 from itself and n minus 2 from itself. So return, so it would be like n minus 1 plus n minus 2. But of course, how do we get, that only gets us back the one number. We need to then go back further. How do we do that? Well, we put the recursive bit in, which is actually call itself. So in this case, we'd say Fibonacci, because that is the name of our subroutine. This is, I always call it fib, so because I'm not very good at spelling. Fibonacci, that one. Whoops. So what's going to happen, as long as I haven't made a mistake, let's say we send it 4. 4 is not 0 or 1, so it's going to say, okay, well then 4 is the same as Fibonacci of n minus 1 plus Fibonacci of n minus 2, and it's going to keep dropping down to get us the value until we get to 0 and 1, and then return n. There we go. Beautiful. And Fibonacci is one of these examples where actually there's a more elegant solution by using recursion as opposed to using an iterative solution.